In this video, we're going to talk about trig identities. Okay, an identity is something that is true for all values. And when we're dealing with identities, it's best to start with a side that looks complex or complicated and prove it to be simpler than it is to take a simple side and make it more complex. The two identities that you're going to need for this class are these two right here. This one is the Pythagorean identity. Hopefully the reasons are obvious. Sine squared, cosine squared, and 1 squared being 1. And then the other one being tangent. The tangent is sine divided by cosine. So using those two and those two identities only, we can make a bunch of stuff happen. Okay. Here's a couple examples. So this is for cosine of x. This is out of your book, by the way. So if any of this stuff is, you just don't get it, try reading the book and see if there's something in there that helps connect the dots for you. But all 8 of these functions around the outside all simplify down to cosine of x. So this is what this section is about, and this is what you're going to be asked to do. Take a complex thing and prove it to be something else. And remember, prove means show. You have to have work. So prove this identity. So what we're trying to do is we have to get one of these sides to look like the other. These 3 lines here means defined as. So meaning we can't move stuff on either side of that like we can with an equal sign. This is a definition. Okay? So I'm going to say the squared side looks like the more complicated side. So it's a binomial squared, so I'm going to have to FOIL it out. So I'm going to end up with sine squared plus 2 sine cosine plus cosine squared. You will find that as I work stuff, and you are allowed to do this too, I will drop the variable just to make things easier. So let's look at what we have on the other side that we're trying to prove. Well, 2 sine cosine, well, that's here, so we're halfway there, and we've got to get 1 in there somewhere. Well, the Pythagorean identity says sine squared plus cosine squared is equal to 1. So that's how we end up with 1 plus 2 sine cosine is defined as 1 plus 2 sine cosine. So that's how you do the trig identities. Okay. Here is another one. This one is kind of a toss-up. Let's see what we can do on this left-hand side. So we have 2 minus sine squared plus 2 sine cosine plus cosine squared. So we know that it is 1 plus 2 sine cosine. So we have 2 minus 1 minus 2 sine cosine. I don't know why I'm putting that in brackets. 1 minus 2 sine cosine. So that didn't get me anywhere. I've got one more trick left. Is I can put the 1 back. I can do the the Pythagorean identity again. So I can say sine squared plus cosine squared minus 2 sine cosine. That I recognize as a perfect square. You might not yet. Let me rewrite it. Sine squared minus 2 sine cosine plus cosine squared. And all of you doubted me and wondered why we were doing such basic stuff. Because it comes back in a more complex form. So this is a squared, this is b squared, and this is 2ab. So we can say sine minus cosine squared. And there you go. Here, I'm not going to go over this one because I want you to do it in class. But what I want to point out is almost all trig equations that have to do with identities are structured in this same way. Okay, and what I mean by that is they're saying show that this can be written as that. Okay, hence means use what came before, right? Hence means use what came before and solve this particular equation. Well, these two are the same. They've already given you the answer, the thing that makes it easier. So instead of dealing with this, you're dealing with this here and solving that. And this is a quadratic. So if you watched all the way to the end of this video, you've got that hint, so you will have a leg up when we get to it in class. So this is the last video in trigonometry. You should have the exact values for common angles. So that's 0, 30, 45, 60, and 90 degrees. I will understand what an angle is and how to measure it, positive and negative. Sign of trig values in the different quadrants. Know how to graph the three principal trig functions for two periods. So from negative 2 pi to positive 2 pi for sine, cosine, and tangent. How to translate those functions around on a graph. How to utilize the inverse of trig functions. How to utilize trig identities. And then how to solve for all of the solutions. Again, here's another reminder of your homework. We've got these here. If you're struggling with any of the material for this unit, check out the additional support problems. That's what they're there for. The other place that's available to you is AICE.